All right, so I think this is recording. Let's take a look at this word problem. It's a mixture problem, and we're going to do it by two methods. We're going to do it by what we are calling the bucket method and then what we're calling the seesaw method. So a carpet manufacturer blends two fibers, one 20% wool and the second 50% wool. How many pounds of each fiber should be woven together to produce 600 pounds of a fabric that is 28% wool? So to help me visualize the problem, I draw two containers for my ingredients. Those ingredients are combined, they are added together in whatever fashion to create a final mixture. And on the, I think of a sticker on the outside just labeling the concentration. So um, we have one, and we're measuring the concentration of wool. So we have 20% wool, and we're going to add 50% wool. So the final concentration should be a number that's between 20 and 50, and we do get that with 28%. And it tells us that the final mixture, the amount of it, the weight of it is 600 pounds. And it wants to know how many pounds of each. So rather than calling this X and calling this Y and setting up a 2 by 2 system with two unknowns, I would need two equations. I'm just going to call this X pounds. And since I know the total is 600, then this has to be 600 minus X. All right, so then to set up our equation that models this, we multiply the concentration times this weight. So it's 20X plus 50 times 600 minus X. And then it's 28 times 600. So if we distribute the 50 through, what do we get? Well, the 50 times 600, make sure that you get the correct number of zeros. And I believe it's 30,000. It's easy to multiply, but 5 times 6 is 30, but then sometimes, I make a mistake sometimes in simply counting my zeros. So if I'm doing that, I'm sure I'm not the only one. 16,800 is what I get for this product. So 20x minus 50x is a negative 30x. And then if I subtract 30,000 from each side, I get a negative 13,200. And if I divide that by a negative 30, negative divided by negative is positive, and I'm getting 440, and that's representing the pounds of this fiber that's 20% wool. And it wants the other amount as well, the 50% wool. So the 600 minus X, 600 minus this 160 pounds of this 50% wool fiber. All right. Let's do the same problem only using our seesaw method. So in the seesaw method, you're really visualizing a seesaw, and the balancing point in physics, they always call that a fulcrum, and you have a weight that you put on each end of the seesaw, and then the distance from that weight to the fulcrum, and you set up an equation that weight times distance is equal to weight times distance. So that's the idea behind the seesaw method. And so we kind of set it up in a table-like form. We identify the weak concentration, the in-between concentration, and the strong concentration. So the 20% wool fiber was the weak, the 50% wool fiber was the strong, and the final mixture was in between the 20 and 50, which was 28% wool fiber. Now the weight, the amount that we had for the week, we let that be our variable x, and because the final mixture was 600 pounds, we knew that this 50% fiber was 600 minus x. All right, so we take this concentration, we take weight times distance. So I need the distance, the difference between 28 and 20 is 8, and the difference between 50 and 28 is 22. So I take 8 times x, and I take 22 times 600 minus x, and I solve this for x. If I distribute the 22 to both terms, $13,200 minus 22x. If I add 22x to each side, I get 30x, 13,200. If I divide both sides by 30, I get 440, and this was pounds of the 20% wool fiber. And we want the other ingredient, which was 600 minus x, and that turned out to be 160 pounds of the 50% wool fiber. And that's the same answer that we got with the bucket method, which is a good thing, right? We don't want our two methods to contradict each other. So I hope that helps, and I will talk to you later. Bye.